This is 4.2 logarithmic functions part 2. Okay, so picking back up on this slide, let's talk about some properties of logarithms. On this slide specifically, inverse functions. So some things that are gonna like knock each other out, right? So on the first one, log base b of b raised to the x power, it's naturally going to be equal to x, and I'll explain that here in a second. It says the logarithm with base b of b raised to a power equals that power. Well, remember, if I have this, 2 raised to some power equals 8. So that's an exponential form, right? And if I was to go to write it in logarithmic form, I'd say log base of 2. So base 2, that's my base, right? It's big over here, but it's still the base on my logarithmic, in my logarithmic form. 2 raised to the x power equals 8. So going back down here, I would say, okay, b raised to the x power equals b raised to the x power, right? So that's a true statement. So because of that, if I have something like this, log base b of b of x, the question that they're asking me here is b raised to what would be equal to b raised to x? Well, we just said the answer, right? B raised to what would be equivalent to b raised to x? Oh, it would be b raised to x. So anytime you see something like this, and what I usually look for is, okay, if these bases are the same, then the answer will always be the power. Okay, and we'll apply this in a second, and hopefully it'll make a little bit more sense. So on the right side, we have in an exponential form, but there's a logarithm in the exponent, right? So if b is raised to the logarithm with the same base, then the number equals this number right here. So again, if my bases match, this base and this base, if these bases match, then they almost cancel out in a sense, right? And my answer will be this number. Okay, so let's go ahead and apply it, because looking at it just with b of x and, you know, b raised to the x power is a little funky. Okay, so the reason that we use that property is because if I'm able to write this 36 with a base of 6, well, then I can get my answer, right? So let's just talk about this. This is log 6 of 36 equals what? So it's asking us 6 raised to what number would equal 36. Now you might know that. You'd say, oh, 6 squared, 6 raised to the second power. But let's say it was values that you didn't know, right? I could write, I'm going to write it over here again. I'm going to write 36 with a base of 6, and I chose 6 because this is my base right here, right? So log 6 of 6 raised to the second power equals, if I'm able to do that, that's a 6. Sorry, it looks like a B, and I don't want to confuse you from the last slide. So because these bases are the same, then my answer will be 2. Now, again, if you can look at this and you could say, oh, log base 6 of 36, well, that's going to be 2. I know that's 6 squared. That's fine, but you'll want to know how to use this property so that when you have values that, you know, you don't know. Another thing is I can enter it into my calculator, right? So going over here, so this is going to be a little bit different. I know I showed you on the last video how to find log when you're in the graph. So let's now see when we're just in the, oh, it's already up. Let me get out of there. Okay, so from this main screen, you will press Math F4 and then see the second option, you'll see log AB. So I'd press F2 and there's my setup for log. So I could just plop in 6, arrow over, plop in 36, and boom, my answer's 2. Yes? So you can use that, but be careful because remember, we don't want to just say, oh, well, I can use the calculator, because if you have some variables in the mix, then you're not going to be able to input that into the calculator necessarily, or if you're trying to get it to another form. So just put that in your tool belt, this property of, oh, if my bases are the same, then my answer will be my exponent. So let me write this in, 2. Okay, so it says log base of 2 of all right, here they want us to find the value of the logarithmic expression. So again, I can just put this in my calculator. I can go back here. I can even go back up to where I already had log. Actually, you know what? Let me go ahead. So you could just input what you want to change it to, but let's go ahead and get out of there so we can practice. Okay, so I'm going to press Math F4. You see math at the bottom of the screen. And then you see log AB. I made the screen a little bit bigger so it's not lined up with the buttons, but that would be above F2. So there we go. So log base 2 of 1/32. And it gives me -5. Okay, so that's the answer with my calculator, but I want to show you using those properties that we just reviewed. So remember, I want to get the bases the same. So I'm going to rewrite this as log base 2, and I'm like, how can I get a 2 in the mix? So I know that I can write 32 expressed as an exponent with a base of 2. This would be a time when you can use your handout that shows some of the exponential values. It's like a small yellow handout, and you can also find that in the document sharing, but it shows you some of the exponential expressions like 2 raised to the 2nd power, 3rd power, 4th power, 5th power. Okay, so 2 raised to the 5th is equivalent to 32. So I didn't change the value of anything. I'm just writing it differently. And I'm driven by trying to get it with a base of 2. Okay, so now I have it like that, but I still don't have a base of 2, right? I have 1/2 to the 5th. So remember how we can move a base from one part of the fraction to the other, and when we do that, our exponent changes signs. So we've used this in previous sections to get rid of a negative exponent, but now, because we want that base of 2, I'm actually going to make it negative. So I'm going to take that 2, and I'm bringing it to the top. Well, if I bring it to the top, it'll be over 1 now, but my exponent will be -5. Okay, so with that rule, that inverse property, we see that my bases are the same, so it will just be equal to the exponent. Now, yes, you can enter into your calculator, but know this property because you'll have to purposefully use it in future situations. All right, again, finding the value of the logarithmic expression. So I can completely enter this into my calculator, right? Let's do that, but then I also want to show you using the properties. So let's go up here so I can show you how I can just go back up to where I had my log, and instead of entering all over again, just replace. There we go. All right, and then press execute, and I get 0. Okay, so that might throw some people off, but let's talk about it. If I was using the property, the inverse property that I just learned in that previous slide, that means that I want to write 1 with a base of 19. Okay, well, what would 19 have to be raised to be 1? Well, 19 times 19, 19 by itself would just be 19. 19 to the first power would just be 19. 19 squared, now we're increasing. So to get it down to 1, remember the rule that any value raised to the 0 power is equivalent to 1. So here, we matched up our bases. So now we can get rid of it and just say it's just the exponent, 0. So look what I'm saying. 19 raised to the what power is 19 raised to the 0? 0, right? So that makes sense. Okay, again, totally can enter this into your calculator. Definitely know how to enter into your calculator. Let's practice again. Let me exit, delete. Okay, so remember I'm going to press math, and this is in this main screen where I'm calculating. This is not to graph it. Remember, to graph it, we have to press option and then calc and all of that. So math, log AB, 6, and then square root of 6. And I get 0.5. 0.5. It doesn't specify what format they want the answer in, but in my math lab, most of the time, they'll ask for it in a simplified fraction. So I just pressed F to D on my calculator to change it into a fraction. Now, again, I can completely enter it into my calculator, but let's talk about that rule so we get the practice of that. Okay, so I want my base to be 6. Well, in order for my base to be 6, it's not 6. You might look at it and say, yeah, I have a 6 there, right? But it's the square root of 6, which is not equivalent to 6. So remember that we can take the index, so this number right here, and put it over whatever exponent is already on there. Well, because we just see a 6 underneath this radical symbol, and there's nothing there, we understand it to be a 1. So it's 1, and then we take this number, and that will be the denominator. So 6 to the 1/2 is equivalent to square root of 6. Okay, and look, our bases are the same, so we know that their inverses, that inverse property makes it where the answer is just going to be the exponent. Hopefully it's starting to click some. Again, you can enter in your calculator, right? So, all right, let's look at this one. So log base 3 of 3 raised to the 8th power. Well, they already have it. They already have it separated. And so we see our bases are the same. So I know this will have to be the exponent because I'm saying 3 raised to what is equal to 3 raised to the 8th power. Do you see? Like I literally just filled in the blank. 3 raised to what number is equivalent to 3 raised to the 8th power? Well, 3 raised to 8 would be equivalent to 3 raised to the 8th power. Okay, now we're using that second inverse property from that beginning slide. So remember, up here on this previous one, we are looking for the same bases, right? So the base of that value and then also the base of the entire log. And if those match, then I can cancel them out and simplify it to just the exponent. And the log is completely left off, right? Here, if I have a log in my exponent, again, it's still, if I have the same base as for the entire value and the same base up here in the log, then my answer will be this value right here. And if you're like, yep, I don't know, now, I'm getting those mixed up, guess what? We can stick it in our calculator. So I'm going to say 3 raised up to log. So I already have it on the screen, but if I didn't, I would have pressed math and then log AB. So see, it's in my exponent. Make sure you put it in the correct spot. It's not being multiplied by the log base 3 of 9. Base 3 of 9. And I get that 9. So when in doubt, well, I don't want to say just when in doubt, use your calculator. Use your calculator regardless to check it. But know the rules, learn the rules, but then use your calculator to confirm that. We have something that we call a common logarithm. And when you just see log x, right? Remember that we'd say log base whatever of this number. Well, when you don't see anything there, it's understood to be 10. Okay, and it explains in the beginning of this slide how, because we have a number system that has a base 10 decimal system, right? So when we talk about like powers of 10, remember that the exponential form is related to this logarithmic form, right? So when I see a log and it does not have a base here, I understand it to be a common log, okay? And in your calculator, you will see a button that just says log. So notice this button next to the X. And when I press it, it just gives me a log. If you use that for other logs besides the common log, you won't get that box next to it, right? Like I wouldn't have been able to enter log base 3 of 9 or log base 6 of 36. So just make sure you understand that when you use this log key, that you are communicating a common log here, okay? All right, so let's go ahead and put log, and then they have a fraction of 1/10. I'm going to use parentheses. And it gets us -1. So something to take into consideration when we do a natural log, and this value right here is a power of 10, then you will always get a value that you can, it will just be an integer for the answer. Okay, so let's see if I could use that previous rule on here. Okay, so I put a 10 here because remember, it's understood that if there's nothing there, that it's a common log. And so log base 10 of 1/10, I could write this as log base 10. And then remember, there's like a exponent of 1 right there. I need to get that base of 10. I'm trying to get the same base as the base right here. So I'm going to take that 10 into the numerator, making my exponent negative. And sure enough, I can get rid of this now, and my answer is just -1. Now, that's just applying that rule, but you saw how I just put in my calculator, and boom, -1 came out. All right, and then they want us to evaluate the log 100,000. So I'm just going to use the log button because it's a common log that we're using, and then 100,000, and I get 5. And remember, I said that we'll get a straight integer for that. Some logs you'll enter in and you'll get these crazy decimals, and so you would keep it as in that format using logs so that you can express the exact value of what you're trying to express. But here, if I can simplify it to, I wouldn't say, hey, by the way, remember that I owe you log $100,000, right? You could be like, what? when I'm just trying to say, oh, remember I owe you $5. So if we're trying to simplify, if we can get that straight integer out, then that's where I would answer. So just applying the rule on this one too, log base 10, because it's a common log of 100,000. I'm like, okay, I can write 100,000 in exponential form with a base of 10. So log 10, since that's a power of 10. So 100,000 is expressed as 10 to the 5th power. Did not change the value. We mark that off, and sure enough, my exponent is my answer. Okay, we have another log, special log that we call a natural log, and this is where e comes back in the mix. This slide right here, I'm not going to go into detail over it, but it basically just explains where the natural log comes from. So all these values that we deal with, like pi and everything, somebody, actually sat down a long time ago and worked things out and was like, oh, wow, this is the number, that's expressed and means this. So when we're talking about a natural log, we see ln to express log base e. So remember that common log, we see nothing there for the base, and it's understood to be log base 10. And then natural log, you'll actually see something that doesn't even look like the word log. You see ln, and that's understood to be log base e. So right here, if I have ln of e to the 7th power, it's the same thing as log base e of e to the 7th power. Well, remember what happens there? My bases are the same, right? So this would be equal to 7. Now you could enter this in your calculator. Let's go ahead and do that. I'm going to do line, then shift, put a 7 up there, and I get 7. But that's why anytime you have that situation, oh, that's going to be whatever the exponent is, because I'm using that inverse property for my logs. All right, the percentage of adult height attained by girls who are X years old can be modeled by, and then they give us a function. There's a log in the mix, where X represents the girls' ages from, so that's going to be important what X is representing. The girl's age from 5 to 15, and f of x, that's our y, right, represents the percentage of her adult height. Use this function to determine approximately what percent of her adult height girls are at age 11. So they give us the age, right? So what is that represented by? Well, it says X represents the girls' age, and it doesn't, specify anything like some of our problems we saw before where it's like, oh, well, X is this many years after this. Nope, it just says that X represents the girl's age, and it's the values between 5 and 15. So 11 falls in there. So we will just plug in 11. Plug 11 in there. I'll circle this in red so you can see that's where I got it. Okay, and this is multiplication right here. Okay, so when you see a value up against a log, then just know that it's multiplication there. So we're going to punch it in our calculator. Have 62 plus 35 times, look at this, it doesn't have a base here, right? So I'm going to use my common log button, and then 11 minus 4, and we get 91.578, yada yada, it goes on. It tells us to round to 2 decimal places, so it would be 91.58, right? That 7 rounds up 58%. Okay, interpreting this. When a girl is 11 years old, then she has 91.58% of her adult height.